Hello class, welcome back to our YouTube channel, and for today's discussion about statistics and probability, we have the lesson 6, identifying regions under normal curve. So from our previous lesson, we already learned how to identify and solve the area for a certain geometric figure. So this time, we are going to identify the areas or regions under the normal curve without using any geometric formula or even a density function from a standard normal random variables. Because we are going to use a certain table and later on, we are going to present it. But before that, let's have our objectives. The learner will be able to first identify the regions under the normal curve of different standard normal values. Second, use the z-table or the table of areas to find the region that correspond to the z-values. And lastly, sketch the normal curve showing the required regions or areas. So previously, we already discussed what standard normal distribution is all about. So let us just recall. Standard normal distribution, it is a normally distributed random variable with a mean equals to 0 and standard deviation equals to 1. And this standard deviation, the 50% of the region or the area can be found to the right side, and the other 50% or the other area, which is composed of 50% or half of the probability, which is 1, is the area below the mean, which is 0. And the other 50% is above the mean. As you can see in this figure, we have the illustration of a standard normal curve which has a mu or mean of 0 and the standard deviation is 1. Now, as I've said earlier, we have the table of areas under the normal curve. This is also known as z-table. So this table gives the area of any values of z from negative 3.99 approximately 4 to positive 3.99 approximately positive 4. And the value from this table will describe the area or the probability of the specific region of the curve to the left of the given z-table. So it's stated here to the left. So we are going to get these areas from the left to right. Now, how are we going to read this table of areas under the normal curve? So first, this is the negative z-table wherein you will see that we have negative z-values. That's why it's called negative z-table. And we also have the a table of areas under the normal curve for positive z values. So we have here the positive z table, positive z values, and these values for the intersection of the z are our areas. So that's why this is called table of areas under the normal curve. And the question is, how are we going to use this table of areas under the normal curve to get the probability? So let's have the z-table or the table of areas. So we have here the z-score. To the first column, we have the value of the tens, decimal tens, or the first decimal. And for the upper part, these are the second decimal place of the z-values. Let's say we have 0.10. So we have 0.1 and 0.00. So this value, or 0.0398, is the area. Let's have another example. Find the area to the left of 1.68. So we are asked to get just the areas from this table. So we have 1.6 and 0.08. So we have 1.6 here, this row, plus 0.08. So we have this column, and their intersection, 0.45335, is called the area to the left of 1.68. So this is how we can use the table, the z-table, or the table of areas under the curve. This is how we can get the specific z counterpart of z value for the area. Now, let us have the steps on how to find the area itself that corresponds to the z value. So the table just represent the areas from the left of the z value. So what if there are other conditions, like to the right of the z values, in between of this z value, and so on? So here are the steps. First, you need to draw or sketch a normal curve and locate the given z value. Second, shade the region of the curve according to the condition of the z value, whether it is below, above, or between. We have the third step. Use the z-table to find the corresponding area. Fourth step, you need to choose the appropriate operation based on the step 2 and 3. So we have three conditions. First, when the z value is to the left, or any related terms such as below, less than of the z value, just write the value we obtained in step 3, or we got from the table, the value that we have from the table of areas under the curve. Second condition, when the z value is to the right, or any related terms there is above, greater than to the z value, we need to subtract 1 by the obtained value in the step 3. Okay? And last condition, we have when the shaded region is in between the two z value, we need to subtract the biggest by the smallest value obtained in the step 3. So the areas of the smallest area is in the left, and the biggest area will be subtracted by the smallest area. And lastly, we have to label the shaded region and draw the conclusion that we have from this that we got from these following steps. And to further understand, let's have example number 1. So for the first problem, we need to find the area that corresponds below z equals to negative 1.35. So for the first step, of course, we need to draw or sketch the normal curve and locate the given z value, which is z is equals to 1.35. So here is the normal curve, and our z value is located here. Z is equals to negative 1.35. It's negative value, that's why it's located to the left of the normal curve. So for the second step, we need to shade the region according to the condition of the z value. So it says here below z equals to negative 1.35. So the shaded region is located to the left. So this region. So it is to the left of z equals to negative 1.35. For the third step, we need to use a table of area under the normal curve to find the corresponding area of z is equals to negative 1.35. So we have here the negative z table. So we have negative 1.3. So here it is for the negative 1.3 column, and the hundreds, the value for the hundreds is 0.05. So we have this column, and the intersection of negative 1.3 and 0.05 is 0.0885. So this is the area under the normal curve based on the table. For the fourth step, we need to choose the appropriate operation based on the step 2 and 3. So it says here, so when the z value is to the left, so because we have below, the keyword here below, so meaning you just need to write the value that we obtained in step 3 as the area. Therefore, the area of the shaded region is 0.0885. For the last step, we need to label the shaded region and draw the conclusion. So here is our shaded region, which is the below z equals to negative 1.35, and this is the value for this shaded region, or the area for this shaded region is 0.0885. And lastly, the conclusion, therefore the area below z is equals to negative 1.35 is equals to 0.0885.